Hey, example 9.
Roots of unity.
Unity. We started talking about this earlier. We're talking about the fourth root of 1. Right?
What times what times what times what is 1?
Exactly.
Yes.
And so but the reason that it's not just like an answer of 1 is we're going to graph each root in the complex plane. It's going to be similar to what we just did actually at the very end of example 8.
Yeah.
So if we're talking about 1, that's 1 plus 0 bi.
By the way, I think this is really neat how this works out.
I. Yeah, no,
honestly,
totally.
I think this is pretty cool.
Yeah.
Because who knew?
I
never did.
Someone did.
I mean, geniusy.
1 is over here.
So r equals 1. Theta will be 0. R equals 1.
Yeah, that's totally what I meant. R equals 1. Theta equals 0.
And the fourth root of unity, so that n is 4, and k is going to be 0, 1, 2, and 3. There's a comma there.
Yeah, this is not my writing day, apparently.
But your writing day is your bad writing day is better than my best writing day. So
I'll just keep going.
Indeed.
So the fourth root of 1,
which we know, by the way, and we'll clean that up in a second.
Okay, and cosine of
0 plus
2k
2 pi
k over 4.
Yes, indeed.
All right. So that's really nifty that's a 0 there. I feel like that's going to be super helpful.
I mean,
somewhat
could be worse.
Well, for one thing, we don't have a fraction on top.
No,
so
we don't have to worry about it. So that's the guy. 2k pi over 4.
2 pi k?
What?
2k pi. Whichever way.
Commutative property of multiplication means that I can say it how I want to, and you can say it how you want to, and we can both say it differently and be the same.
The fourth root of 1 is
1.
And so really, do we even need to write 1 parentheses?
I mean, not in this case, I don't think so.
Do you want me to leave it as 1 parentheses?
It's up to you. You're doing the right today. I'll let you make those big decisions.
Okay, well, if I plug in a 0 here, I get 0.
Oh, so hey, looky there. By the way, we can do that. The cosine of 0 is...
Cosine of 0 is 1.
The sine of 0 is
0, which makes this 1 plus 0i.
Hey, that's...
Which is just 1.
That's 1. That's where we start. Okay, k equals 1. Now this is where it gets really fun and exciting. Okay? Because now we're going to have 2 times... who was that kid?
It's one of my students. 2 pi over 4 times 1. So that's 2 pi over 4.
Which is pi over 2.
Pi over 2.
Plus I sine pi over 2.
Hey, we can figure out what that is.
That's going to be 0 and 1.
Yep, just go right around the unit circle. So 0 plus
I smell a pattern.
K equals
I'm going to take a stab at what's going to be next.
Okay.
I'm just going to take a guess. It's
like
going
the
to
standard
be
form?
-1 plus 0i.
Okay, yeah. Because
now when you do 2k times 2, that's 4 pi over 4, which is just pi. And everybody knows the cosine of pi is -1.
Everyone. That's general knowledge.
General indeed.
And sine of pi is 0.
Yes, that's also general knowledge.
And k equals 3?
I'm just going to guess that it's going to be 0 and -1i.
Okay.
Just guessing. Why? Okay. Why do you ask? Why? Why do you ask? Why?
Why do I ask what?
Why do you? Because 2 times pi times k in this case is 3, so that's going to be 3 pi over 2.
Okay. I'm not sure what just happened.
Math happened. Math is happening right now.
No, in the conversation.
Math happened in that conversation.
Cosine of 3 pi over 2.
0.
0. Okay. And sine of 3 pi over 2. -1.
-1.
That was a close one, actually. I almost screwed that up, but I didn't. So
thank
now,
goodness.
What happens if we graph this? Now we've got 1, 0, which is here. We've got 0, 1, which is up here. -1, 0, 0, -1. Look at how these are all equidistant apart. They're all 90 degrees apart. Okay, so that's what should happen. If it's the fourth roots, there should be 4 things going on here that are all equal.
That are all the same distance.
If it was the third roots of unity, or even third roots in general, I guess. Well, the third roots of unity, you'd start here again, right? But then you're dividing the circle into thirds. So over here and over
down there
here.
somewhere, yeah.
Okay, because that's dividing a circle into thirds.
That's a great circle.
Totally. That's the best circle
Yeah.
ever.
But this is really a cool thing. And so if we ask you to do like the eight roots of unity, it really shouldn't be a problem once you get the first one.
Yeah. Well.
The second one.
Yeah. Because this one worked out really nicely because they were on the
fours,
quadrants,
yeah.
but otherwise we might have wanted to use the pattern
That is
they were
correct.
all pi over 2 apart.
Right.
Or actually, we could have used the pattern in that.
Yeah.
Whichever.
Indeed.